Okay, so is this decay or is it growth? And how do we know? Growth?
Yeah.
Why?
Because it's increasing.
Because it's increasing. So we have 580 billion ton miles, whatever that means, right, in 1960. And it increases by 2.32% each year. Okay? Which means we get this guy. Okay? And so every year it's going to increase. Does that make sense? So we need to make up a function for it. Okay? So we have a start, right? And the start is 580. And then it's going to be increasing by 1 plus, now is it 2.32?
Yeah. Yes.
No.
No.
Because this is a percentage, so it has to be 0.0232, right? Because we have to change it to a decimal, right? 0.0232. Okay? And then we're going to raise that to the power of the time. Like how much time will go by, right? And so they want to graph that. Well, then the function with respect to t is going to equal this. And we can graph that. It's pretty easy. If we go to Desmos, right? We go on to Desmos and we put in there, well, y equals 580, right? Times the quantity of 1.0232, right? And in the quantity, and then we're going to raise it to the x. Okay? And then we got to look for our graph. Okay? So here's our graph. And so we can see our graph, and we can see it crosses at our 0 time would be that 580, right? 580. That makes sense. So our 0 time is really not 0 time though, is it? It's 1960. Does that make sense? But when does it get up to 1,000? So when does it get to 1,000? And it's like just a little bit past that first dash. So if we come all the way down, and what's the first dash? Where there's 1, 2, 3, 4, 5 hundreds, right? So it looks like it's somewhere around that first dash should be 20. Does that make sense? Now, Desmos is a little better than that. We can actually go up to 1,000 and click on it. Try to click on it. Right? And we got, oh, there's 1,000. 1,000 is at 23.78. So, 23 years later, right? 23 years later, or 23.78 years, so maybe 24 years later, it's gonna be higher. Because at 23 it wouldn't be higher, right? But at 24 it will be higher. Does that make sense? At 23 it's still going to be at 900 and something, right? 909. But at 24 it's going to be at 1,000 something. Does that make sense? So it's going to get past it at 24 years. What's 24 years past the... and so this is what our graph looks like. And then this is at 580, right? And then, you know, great, we got a graph. All right? But where does it exceed? 24 years past 1960, which is how much? 1984. So if it increases that much, by 1984, it'll be at 1,000 billion, right, ton miles. Does that make sense? It's just your basic formula. You're just plugging it in and checking it out. Okay? Your formula for growth. Okay? And then you can plug it into your calculator and tell it to graph it and learn how to read the graph. You could also plug in times here, right? And go, hey, what is it at 10? What is it at 20? And at 20 you would have seen, oh geez, this is like 970, right? You'd be like, ooh, what's 21? 22, 23, 24. 24, it beat 1,000. Does that make sense? So every time you plug in a number, you could figure it out. You can say, well, 580 times 1 point this raised to the 24th power times this is going to give me 1,000. Okay? And right now it's trial and error. We need to find a way to do this without trial and error. Logarithms. Okay?